Hello everyone, welcome to Digital Electronics and Computer Organization course. I am Sudhakar Ajmera, Assistant Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Today we will discuss about combinational and sequential logic circuits in digital circuits. Generally, we will use these combinational logic circuits as a part of digital circuits. Okay. So, digital logic circuits are building blocks, or these are the fundamental components in modern digital electronics, okay, which will enables operations in systems like computers, mobile phones, laptops, calculators and so on by processing binary data through logic gates. So, such logic gates will generally use AND, OR, NOT or universal logic gates. Okay, these are essential for tasks like these logic circuits are used for storing data, for decision making and control functions as part of digital circuits. Basically, digital circuits are of two types. These are categorized as two types in digital electronics. So, such as one is combinational circuits, another one is sequential logic circuits. Let us see one by one what do you mean by combinational logic circuits, what these combinational logic circuits will do. So, in combinational logic circuits, the output at any given time depends on current inputs only, not on past inputs or states, I can say. So, these outputs are depends on only present inputs. Okay, these inputs can be of n number of inputs and output can be n number of outputs. Since these circuits are not depend upon previous input to generate any output. Okay, so these circuits are fundamental in performing tasks like arithmetic operations and data routing and comparison. Okay, so combinational logic circuits outputs depends on only present inputs. They don't have memory elements to store previous outputs. Whereas these sequential logic circuits are quite different from combinational logic circuits, okay, in this sense that they employ memory components. So, in sequential logic circuits, we will use memory elements such as flip-flops, okay, or latches. Okay, to get this output from memory element, I need to provide additional clock input. So, based upon this clock input, I can get, okay, memory block output, and again these inputs I need to give to combinational logic circuits. So, what I mean to say, these combinational logic circuits, these outputs depends on inputs as well as previously stored outputs which are available with flip-flops or memory elements. So, what I mean to say, with these logic circuits, output depends on present inputs as well as past outputs. Let us see comparison of combinational and sequential logic circuits. So, I can compare combinational and sequential logic circuits with respect to so many parameters. Let us see first, we will see definition, how this combinational logic circuits and sequential logic circuits differ in terms of definition. So, as we have discussed right now, combinational logic circuits outputs depends only on current input or present input. Let us see here. So, these outputs depends on only present input only, not past output. And for sequential logic circuits, the outputs depends on both current inputs as well as past states. So, because why I am saying states means previous outputs stored in memory elements here. So, memory elements will provide state output based upon clock input. So, I can control sequential logic circuits with the help of clock. So, here I can use memory elements as flip-flops or latches. So, here with respect to memory elements, here in combination circuits does not require memory elements, whereas in sequential logic circuits memory elements are required. Memory elements will use for sequential logic circuits as flip-flops or latches. Okay. Let us see time dependency. Okay. Here as we won't use memory elements, so here output is immediate, we can get it based on input changes. But whereas for sequential logic circuits, output is dependent on clock pulses, as we have discussed here. As soon as clock I will give, so output I will get it from this memory element, and I can give this input again to this combination circuits. So here what I mean to say, for sequential logic circuits, memory device output depends on clock input. Hence, overall sequential logic circuits output depends on present input as well as past output, which are stored with memory elements. Here for combination logic circuits, we won't use memory elements. So clock is not required. So there is no clock signal required for combination logic circuits. Whereas for sequential logic circuits, I will use memory elements. That is why clock signal is required, and which is synchronized. Next, as soon as I won't use memory elements in combination logic circuits, that is why it is simpler in design. Okay. Whereas for sequential logic circuits, I will use memory element. That is why this sequential circuits is little bit complex compared to combination logic circuits. So it is more complex because I will use memory and clock circuitry additionally. If you see the speed of combination circuit, okay, so combination circuits outputs changes instantly because I won't use memory elements. That is why it is a faster circuit compared to sequential. Whereas as we have discussed right now, okay, sequential logic circuits are complex compared to combination logic circuits. That is why it is slower due to some dependency, because the output is depend on present input as well as past output, and it depends on clock cycles and past states. Let us see functionality of combination circuits, which performs basic logic operations without sequence dependency. Okay, whereas for sequential logic circuits performs sequences or timed event because I will use clock circuit. So best example for combination logic circuits are adders, subtractors, multiplexers, encoders, decoders, and so on. Whereas for sequential logic circuits, all types of counters, shift registers, flip-flops, and state machines. These are what the examples of sequential logic circuits. Okay, because these sequential logic circuits, counters, shift registers, flip-flops, state machines, all these required or work upon clock input only. Okay, whereas these adders, subtractors, multiplexers, encoders, demultiplexers, decoders doesn't require clock input. So as of now, we have discussed introduction of digital circuits and its types, such as combinational, and another one is sequential logic circuits. Okay. Next topic we will see adders, subtractors definitions along with its types. Okay. So there are the types of adders and subtractors we will see in next class. Thank you.